Okay, today we're going to talk about how, okay, so last class we drew that line, right? We plotted our points and we drew what we thought looked like the best line. But how do we actually calculate that line? We know there's correlation, we can draw a line, but how do we get the best line? And so let's say I graphed it on my own, right? And I created my own equation. So let's say here's our backpack data, right? We put the backpack data in, we get the scatter plot, and we have an equation. So this is our regression line. Y hat is the equation, y hat equals this. So if you put in the person's weight, this is their predicted backpack height. And so the residual, which is what we're talking about here, the residual is how much the observed value differs from the predicted value. How much the observed value differs from the predicted, and it's the y's. So here is the observed value, this is the predicted value, so this is the residual. This is the observed value, this is the predicted value, this is the residual. It's this minus this. So this is a positive residual, and this is a negative residual. This is a negative residual, positive residual. Because it's y observed minus y hat. That's going to be the residuals. So what we want to do is we want to minimize the residuals. And so mathematically how we do that is we find the point that reduces the squares of the residuals the least. And this is what's known as the least squared regression line, or LSRL. And that's the least squared regression line. And LSRL is a acronym that you can use on the AP exam. And you can play around with this. There's several calculators online. There's other examples in your textbook. You can play around with these. But the basic gist of this is that as we move this line, we're going to find the equation that minimizes these squares. And it's easy to find the minimum of a squared function. It's the vertex. And someone went through and did a lot of the math on this, and they came up with the equation. You can try this. This isn't working here, but feel free to type this in and play around with it if you want to really understand how least squared regression works. But what we'll come up with is, the other thing that eventually we're going to get into is we're going to look at the graphs of the residuals. And so a residual graph looks like this, which is where instead of all we do is we graph the residuals. And when you do that, your regression line becomes the x-axis, and we're just looking at how much above or below. And we'll talk about this later in the year, and we'll show you how to do this on your own. And this isn't exactly right, because then this would actually be here and here and here, but we're getting the general gist of the graph here. And so you would see these points, and that would be your residual graph. Patterns in the residual graph are bad. We don't ever want to see patterns in the residual graph, and we will get into that later on in the unit. For now, we're going to talk about how do you actually calculate this line. Right? So we got our points. How do we get it? And most of the time, you're going to do this using the calculator, but occasionally they will ask you to do it by hand. The key is R. Once we have R, calculating the LSRL is easy. And in any problem where they ask you to calculate the regression by hand, they'll give you R. Like, they're not going to ask you to calculate R. They would give you R. And so the formula for the regression line is right here. Now, what you will find is that we were, in Algebra 1, we always did y equals mx plus b. And in regression, it's kind of backwards. We're going to call b the slope and a the y-intercept. And the reason for this, it's not in the scope of this class, but eventually you can regress for multiple variables, and you just keep tacking them on at the end. And you account for more and more variables as it goes on. We are only going to do 2 variables in this class, but that's why they write it backwards. And so once we have R, then the slope of the line is just the standard deviation of y divided by the standard deviation of x times r. Now, because the LSRL always goes through x bar, y bar. X bar, y bar is always a point on your regression line. The average x value and the average y value. Then we can use the slope here, and we can just plug in and we'll get the y-intercept. Slope is very important. Y-intercept is important in creating the line, but often has no useful application all besides creating the line. Slope, though, gives us a lot of information. And we'll talk about that. But you need to know these equations because it is possible on the AP exam that they would give you S sub y, S sub x, and r, and they'd ask you for the equation of the regression line. They wouldn't give you the data points, so you couldn't put them in your calculator. These formulas are on the formula sheet, so you need to be ready to go. But basically in the next class, what we're going to be doing a lot of is calculating regression lines and finding the least squared regression line for 2 variable data sets. So that's it. Short video again tonight. Read over the part of your textbook, and we'll see everybody next class.